higher order derivatives. If y equals f of x, then its derivative is dy dx or f prime of x. We often call this the first derivative. Let's look at notation for higher order derivatives. For example, if I write this down, d squared y over dx squared, that's how we say it, but nothing is being squared. I want to emphasize that. We are not squaring anything. This is simply notation. This really means the derivative with respect to x of our first derivative dy dx. In the other notation, we would call this f double prime of x, which is the second derivative. And so on. If I were to write the following, d cubed y over dx cubed, nothing is being cubed, it's just a notation. We would call this f triple prime of x, or the third derivative. Now after this, we start changing the notation slightly, at least I usually do. Not on this side. This would be the fourth derivative. I'm not going to write down fourth derivative, but we call this the fourth. But instead of doing f with 4 primes or 4 slashes, we put it in parentheses. So when you see this, the exponent in parentheses, that is the order of the derivative. In this case, the fourth derivative. And in general, you might see it like this. This would be the nth derivative of the function f. Let's do just a couple examples. Let y equal 6x cubed minus 10x squared plus 5x minus 1. And we want to find the following, which simply means find the second derivative. Well, to find the second derivative, you have to find the first derivative. So let's find dy dx, which is 18x squared minus 20x plus 5. And then the second derivative, a reminder, it is the derivative with respect to x of what we just found. We don't need to write this down, but I'm doing it for later on. It's good to know this notation is going to help us in certain situations later on in the course. But all we got to do now is take the derivative of what we just found. So the derivative of 18x squared minus 20x plus 5 is 36x minus 20. Let's do one more example. Suppose that f of x is the square root of x minus 1 over x. And let's write the equation of the tangent line. And let's do it not to f of x, but to f prime of x at x equals 1. So we're going to need 3 things, as always, when we write the equation of a line. We're going to need the x value, which we have as 1. We're going to need the y value, but you have to think of the y value as being my f prime of x. And then we're going to need the slope, which is going to be the derivative of f prime of x. Notice how I mixed and matched my notations, that's fine. Which is going to be f double prime of x. Let's find f prime of x. So the derivative of the square root of x is 1 over 2 root x. The derivative of negative 1 over x is positive 1 over x squared. Now, I've written this so many times, I like this notation, but honestly, this might not be the best notation to use, especially if we have to go forward. It's nice to put it like this when we plug in, so I do need to plug in. But I also really kind of wanted the other version as well, which is if I look at f of x being x to the 1/2 minus x to the negative 1, then I get its derivative is 1/2 x, and subtract 1 to get to the new power, to the negative 1/2, and then minus negative 1 x to the negative 2. So my y value is my f prime value, so f prime of 1 equals 1/2 plus 1, which is 3/2. And now we need the slope, which is the derivative of f prime, or f double prime. And so I'm going to use this form over here to take the next derivative. So I get negative 1/4, because I bring the power down and multiply by the constant. And I'll subtract 1 to get the new power. And then over here, I will do plus a negative 2, because I'm bringing the power down in front, times x, subtract 1 to get to the new power, which gives me f double prime of 1 is negative 1/4 minus 2, or negative 9/4. And now we can write the equation of the tangent line to f prime, which is y minus the y value equals the slope times x minus the x value.